Okay, so welcome again, everyone. Thanks for joining today, this monthly Frictionless Data Call. Today, we're going to hear from Nick Kellett and Pan Kantidara about citizen science and climate change data and how they use frictionless data to do so. They work for Deploy Solutions, and they're going to tell a lot about this, but let's maybe start with a quick round of introductions so that everybody knows everyone. I can maybe start. I'm Sara Petti. I'm the community manager for Frictionless Data. I'm based in Bologna, Italy. Well known maybe for its lasagna and bolognese sauce. And it's incredibly hot in this time of year. It's around 30 degrees Celsius in this moment, which is quite hot considering it should be still spring. But yeah, anyhow, I'll just pick someone else to go after me, and then we can just go around with a round robin. And then I propose that Pan and Nick, maybe you go last, so that then you can directly start the presentation. Okay, Carles, why don't you go next?
Yeah, happy to go next. Yeah, I'm Carlos. In my previous work, I used to do things with Frictionless. I was working at the Swiss Pole Institute, not anymore, but I still like Frictionless, and we are doing a project. I'm working on open source projects, usually education, so it's always in my kind of tooling to use or to know and to expand if possible. Yeah, a year ago I was one of the when I wrote a small tool for Frictionless as well, so I've been involved in different ways. And I'll choose next maybe Nicholas Singh. Did you say no to Nicholas or to Nick? Okay.
Okay. Yeah. So I'm not the host. I'm not one of the presenters. But anyway, so my name is Nicholas Singh. Yeah, I'm based in Melbourne, Australia. So I'm a PhD student here. Yeah, I was interested in rebooting this group in Australia because it seemed to sort of collapse a few years ago. And yeah, I was interested, and I was just talking to Sarah before, and we found out that you had this Zoom call just after our meeting. So yeah, I figured I'd attend to learn more.
Thanks, Nicholas. Would you like to pick someone else to go after you?
Okay. Oh yeah. Oh, sorry. Okay. Anyone. Edgar.
Hi, I'm Edgar. I'm located in a small town called Rapallo in Italy, and I work as a developer in Open Knowledge, and I contributed to Frictionless, one of the projects that work there. And yeah, that's it. I pass to Dana.
Hi, I work with the Biological and Chemical Oceanography Data Management Office in Woods Hole, and we've used just to help us with our laminar pipeline, our processing tool. And in a different job that I had, we did a ton of citizen science, so I thought I would jump on. Thanks. Sorry, I have to pick someone.
Yes.
Sorry, Jonathan.
Hey there, my name's Jonathan Mitchell. I'm in Washington State in the US, and I work as a software developer for a company called Innovi Health, and just love the frictionless concept. Want to see more of it. I'll pass it over to Augusto.
Hi, I'm Augusto Herman. I'm based in Brasília, Brazil. I used to run the Brazilian federal government open data initiative many years ago. But now I just work as a data engineer, automating data pipelines in the ministry. And I also help publish some open data sets and try to use Frictionless wherever I can. I also contribute voluntarily to many open knowledge projects, including Frictionless, now and then. And I'll pass to, don't know how to pronounce, but Aditya.
Yeah, I think Aditya is using a bot, so I'm not sure that she can speak. Let's wait a
Okay.
second and see, but.
Okay, then Mike.
Sure, I'll pop on camera real quick. I'm Mike Tresnide, based in Washington, D.C. I work at the Smithsonian Institution, and still, I think I came to last month's meeting and said I was just getting started learning about frictionless data. I'm still embarrassingly at the same spot, but more use cases are always great. So that's why I'm here. Okay, and I see two pans. I'm not sure. They're both the same person signed in, but
They are both the same. So I am I'm talking and video calling in one computer, and I have a demo on another one.
Pan, do you want to introduce yourself, I guess, at this moment?
Sure. So I am Pan, and my last name is really long, so I'm not going to introduce it. And I was originally from Thailand. I am in Vancouver at the moment, and I am a software developer, and I do web, I do mobile, and I am working at a deploy solution as a tech lead at the moment. I'm not a data person, and I don't use a lot of Python, but I have been exploring Frictionless SDK, Python SDK for data validation, and I found quite useful. So Nick, or
Sure. So who hasn't gone?
I think Dan still needs to go, Justin and
Dan?
Sassi. And I think that's it.
Dan?
I'm Dan Fader. I'm in Philadelphia. I work for a company called Civic Actions with the Centers for Medicare and Medicaid Services. We do kind of a group of open data portals there with DCAN, which is a Drupal-based open data platform that we maintain. And yeah, I've been on a lot of these calls. We're looking at ways to integrate more with the frictionless ecosystem. I'll pass to Lily.
Thanks, Dan. I lost my mouse. I'm Lily. I'm the product manager for Frictionless Data, and I'm really excited to hear about the talk today and learn more about the citizen science stuff. That's an area that I think is really important for open data and, well, for a lot of things, including climate science. So yeah, I'm just really excited to hear more. And I'm based in Austin, Texas. It's not quite as hot as it is in Bologna, Italy yet, but it will be soon. And I will pick, let's see, who hasn't gone? Sassi.
Hi, I'm Sassi and I'm from Nepal. I'm currently working as a developer in Open Knowledge Foundation, and I'm contributing in Frictionless Data. And nice to meet you all.
Thanks, Sassi. Justin, I think you're the only one left before Nick introduces himself and gets the ball rolling.
Thank you, Sarah. I'm Justin Mosby. I work at Deploy Solution as an R&D Innovation Manager. I'm currently based in Kingston, Ontario, Canada. Back to you, Sarah.
Thanks. And Nick, why don't you go ahead?
Okay, I'll share my slides. So I'm Nick Kellett, founder and CEO of Deploy Solutions, working with Pan and Justin and many others. We have some commercial activities, but today we're going to be talking about something that's the non-commercial side of things that we're interested in, which is identifying ways that software can help with climate change, including the use of citizen science. That's an element of it. So I'll start by sharing my slides. Let me know if you can see that. Does that work?
Yes.
Perfect. Okay, building software solutions for climate change using Frictionless. We actually had a presentation yesterday to a group, and we subtitled it "The Need for Speed," because we need to deploy these solutions very, very quickly in response to the disasters that are unfolding. We've been building a prototype. I'll talk a little bit about that. That dates back to a 2017 and the 2019 disaster in this area. But in the process of working on this, there've been lots and lots of other disasters in Europe, in Australia, in the US, South Africa, all over the place, of course, and more on the way. And in fact, this last weekend on Friday, unfortunately, our city was hit again by a giant storm that impacted the most populated and industrialized part of Canada. And there are some people who are still without power, and it's caused significant impact. So we are hoping to launch a solution that can help people as quickly as possible, and Frictionless is a key element of that. And even though we're new to Frictionless as of just a few months ago, we sort of jumped into the deep end, and we're very happy with the results so far. So we're going to talk about that today. So briefly, we're Canadian software developers. We're passionate about space and the earth. We are experts in software research, development, and innovation. We build cloud-hosted solutions using big data from space, so a lot of Earth observation. That's kind of where we came from. We help organize an annual hackathon, the NASA International Hackathon in the Ottawa area. And again, as I mentioned, we've been focused on climate change research since 2019. So the problem that we're facing is the changing landscape. We're effectively making the Earth more hostile for ourselves and the living creatures on it. And we're concerned about that. So we started asking questions, several years ago, talking to people for about 30 minutes at a time via Zoom, and asking them their opinions of climate change issues, impacts, and things that might prevent them from taking action to prepare for these or to deal with these. We talked to citizens, NGOs, scientists, government officials, everybody we can talk to. Some of this was 30-minute interviews, some of it was surveys. There's a lot of secondary research that was done as well. And we focused on the top communication problems that prevent citizens or individuals and communities from acting on climate change risks. And we've been working on prototypes to build software that will help with that. So far, we have talked to over 75 people in Canada. We've talked to hundreds of survey participants. We've had 140 students in 23 academic institutions across the world assist us in one way or the other. We think that'll be up to about 200 by the end of the year. So we're really heavily focused on working with students to try to explore concepts. Frictionless helps us with that as well, and we can talk about that a little later if you're interested. And the top problems getting citizens to act that we've identified are three. One is that they feel overwhelmed by the volume and variety of the information that comes at them when it comes to climate change. The second one is just as important, it's related, that they feel that they get information that isn't personalized for their actual needs. So they don't really know what to do in their particular situation. And then related to that, authorities have difficulty directly collaborating and sharing information with citizens. It's not that they don't have ways of sending out an alert or information or so on. It's just that people are getting that information from a variety of different places. They'll get it, an alert message on their phone. They'll have a municipal website they can go to get information. They go on social media and they find out from groups, community groups and so on, or from their friends and family. So they're totally overwhelmed by this and they're not sure exactly what they're supposed to do. And the authorities themselves aren't sure if these messages are even being received. So these are the top three problems that we've identified through this period. So how do we build solutions for that? The software solutions. We've broken it into two. One is the citizens or the individuals in the communities, and the other is what we call the trusted authorities, which is an interesting term. And we thought long and hard about it. Some people obviously don't trust the authorities, or they trust them with some things, not with others. So this is contentious, but we've come up with definitions for this. We've done a lot of research, and we've got a working definition. But at a high level, we've broken the solution down into the individuals in the communities and the trusted authorities. And the questions that keep coming up when it comes to preparing or acting are things like this. Where can I find the nearest emergency shelter if there's an emergency? People wonder where they can drop their pets off while they're in the shelter. They want to know where they can get gas or electricity. They might want to help people. They're not affected, but they want to help people. So how do they do that? Where do they go? What can they do? Which emergency shelters are full? This is something that an emergency response official might want to know. Which roads are blocked by water accidents or fallen obstacles? Obviously, anybody might want to know that. So these are the questions that arise based on a specific disaster impact that's unfolding that are unique to that disaster impact, but that people would really want to know about. And again, they're getting this information, if they're getting it from the radio or from social media or from a variety of places. So what we're proposing is to very quickly, probably in the space of about 4 hours or less, create a complete web application that would have basic functionality to provide this information. So you can see in this example, it's based on the 2019 flood that happened in our area. I might, as an individual, be able to go to this website, don't have to create an account, don't have to log in, but I would find important information on the water level, the precipitation, information on my insurance company, contact information that's important. I can submit citizen scientist observations, which we'll talk about. I would have a list of practical advice that's given to me that is based on the particular disaster impact. In this case, it's a flood. So, it would say things like, you will be notified if the municipal drinking water is unsafe to drink. Assume that everything touched by floodwaters is contaminated. Check for foundation and structural damage. And each one of these items that you could look at would have very targeted advice and very practical advice, maybe some photos that would tell you how to do this task. And it could be broken down into the before, during, and after period of the disaster. So it's only showing you the information that's useful to you based on this particular impact and the phase of the impact that this is. We would also want to get curated news, so not fake news. There's a lot of disinformation, misinformation these days, as we all know. So there would be a section that allows these curated media websites, national or local, social media accounts, sometimes for the municipalities, sometimes for NGOs or other groups that are involved in the preparation or response or recovery of this disaster. And this would be a way of cutting down the fake news that abounds. And we think such an application would be map-centric. That's the way we're building it. So you would have the ability to see information like where's the water level reaching to, what are the flood extents in this example, or where are the sandbag locations you can go to, or if you need help, where's an emergency shelter, and so on. So the idea is that on the individual or community side, you would have this, this experience. Again, you don't have to log in. We also think that people could be citizen scientists, and they'd have the ability to upload information that would assist the authorities with responding. So we're partnered with a company called Catalyst, which is an expert at algorithms and making sense of geospatial and Earth observation data. We're supported by the Canadian Space Agency under their Smart Earth initiative. So we embarked on this project about 6 months ago now. It's a long-running R&D project. And essentially the idea is to take Earth observation imagery from satellites and apply machine learning algorithms to them, but at the same time associate the imagery that citizens are taking on the ground with those observations in order to identify whether the algorithms are accurately predicting the flood extents, or to identify areas of infrastructure that might be at risk, or public safety issues and so on, and associate those with the satellite imagery. So that's the idea, to combine the satellite imagery with the ground truth. So the idea is that an individual would be able to take a photo on their mobile device or a video or more than one, upload that to this trusted authority section. The trusted authorities would be able to look at this information and curate it, and then they'd be able to attach it to the satellite imagery processing algorithms that are in effect. So that's what we're working on right now. The authorities themselves would have a set of data. It would depend on the disaster, but you wouldn't, imagine that they care about things like, where are the hospitals, where are the emergency shelters, where are the sandbag locations, where are the emergency supplies, and so on. These are the kinds of information they would want to know about, and we want to be able to place that on a map very, very quickly. And ultimately, there would be a data analyst aspect to this. So the ability to visualize the data that's coming in, to look for trends or outliers, as well as gather historic data for the precipitation and compare it to what's predicted, or whatever the other particular need might be. This is to allow the data scientists to grab the data and work on it. So again, we're using the Ottawa-Gatineau floods of 2017 and 2019 as an example. So this is precipitation data from the Ottawa area weather stations, and this is how that reporting works. So we really, I skimmed the high-level functionality. There's a lot more than this. We are actually building a working prototype that does these things. But the key point is, as I think you can start to see, there's a lot of different information that's needed. And we were looking around to figure out how we would make sense of all this data, especially a lot of it is tabular, it's CSV data. And there was really no way to describe the data. We would go to a website that had a list of municipal infrastructure, and that would be different from the municipality across the river, or that would be different from the municipality on the other side of the country. And so although we were able to find open data, we weren't able to easily describe it once we brought it into our system, and therefore develop against it. So again, we broke our solution down into the citizen side and the trusted authority side. We also have a technology that allows us to rapidly produce these software applications. Again, we want to do that in 4 hours or less. And that's also a problem because we were trying to use CSV data to build these solutions very quickly. And we didn't really have a way of saying this is what that CSV column means. We didn't have a way of validating the data that was being gathered. So these are all gaps in our ability. So the list of schemas so far, we're working on that, but these are the examples. I've touched on some of these before. You know, the schema for where are the police stations, the hospitals, the healthcare facilities, what are the local news sources, what are the gas stations that are nearby, what are the hydro stations, what are the emergency shelters, sandbag locations, and then, as I mentioned, the citizen science observations and videos and photos. We have created and are continuing to create frictionless schemas that describe these totally different sets of data in a way that allows us to standardize them, and that's really what's so important to us about it. So with that said, I'm going to switch it over to Pan. She's going to show you kind of a working progress of how we validate against the schema. So Pan, I'll stop sharing and hand it over to you.
Thank you, Nick. So as Nick mentioned, we are working with a few set of data, and I'm going to pick the police station schema here to do a demo on you for you. And so here we have a police station schema with the creation time, ID, names, and we specify the type of each field of the data in the schema. And what we are trying to do is we are trying to validate the CSV data that we have. This is the valid CSV that we want to upload. This is not, and we could try with like a random CSV. And we are using the frictionless Python function, the validate function. And what we do here is we create a resource from a user uploaded CSV along with the schema, the police station schema. And once they do an upload, they will specify what type of data it is that they are uploading. Then we'll validate it against the schema and give them the report. Well, basically, if the data is valid, we will upload the data to S3 and process it. But if not, then we'll return a response.
And can I just interrupt you a little bit? Can you maybe make the font a bit bigger somehow?
I cannot.
Okay, then never mind.
But I know in Zoom you can actually expand the screen, the viewing.
Yeah.
Screen.
True.
Yeah.
Yes.
So yeah, sorry about that. Yeah. So what the code does is basically calling frictionless validate. Well, it makes a resource and calling the validate function. And over here, this is the API that we created for the user to upload a CSV, and we take in a base 64 data of the CSV, and as I mentioned, we'll specify the type. So I have here the base 64 of the the CSV data. Well, I'm just gonna convert this to so the police station. This is the CSV that, as you can see, the latitude have an invalid, a mismatched type of data in here. So if I were to upload this file and do a test here, so we'll get a response saying that there is a type error in exactly which cell, which row and which position, and it will not upload. So this is where the CSV would end up if it's validated successfully. But as you notice, nothing get upload here. And then if we were to fix that, and so now we have this data here where we have the right format of data. So I'm going to upload this. Oh, sorry, I don't think I press that. So now we will say CSV successfully validated, and this CSV that we uploaded ends up in this S3 bucket. So basically, we used frictionless schema to prevent any bad data, any invalid data, to basically ends up in where we want to collect. So so yeah, I found it's really helpful. And I mean, I have this random data here that it will just kind of blows up, and yeah, that will be a lot. There will be a lot of data of errors, so it would actually list of all of the field that were wrong with it. So yeah, so I think that's kind of conclude my demo. Does anyone have any questions? Okay, so I guess I'll pass it back on to Nick.
Thanks, Ben. So the key point, I think, because of what we're trying to do with the climate change disasters, they're different, right? It's very different, obviously, if it's a forest fire versus a flood. And what we're finding, sadly, is these are all starting to affect each other and compound. So it's a forest fire, then a landslide, then a flood, then the power goes out, then the highways are cut off, and now there's a supply chain issue, right? These are all different problems as part of the same unfolding disaster for a group of people in a certain area at a certain time. And so we cannot possibly guess ahead of time what all the different data sets are that are relevant. Therefore, we have to generate these very, very quickly. And without Frictionless, we have no way of ensuring that the data that's quickly being generated, which is coming in all different shapes and sizes, is actually valid. And therefore, it breaks our application and it introduces uncertainties and risks. And so Frictionless is the key to us because not only is it ensuring the scientific rigor and validity of these data sets in terms of the actual application that gets produced, but it allows us to actually develop the application itself in a hurry. So again, we only started using Frictionless a few months ago, really. I think November, December, we were starting to look at it. But it became clear that that was a missing piece for us in terms of our work. And although we're still very early days, we are already expecting that we're probably going to extend the Frictionless schema for some of our purposes. We're going to go deeper into some of the tooling, all the great work that you've all done. We're going to try to leverage that and contribute back to that. But we see our use of Frictionless growing and not decreasing, if that makes sense. There's one more thing I wanted to mention. I sort of didn't introduce it before, and I apologize for this, but we actually just finished working with students, teaching them how to create data sets for us using Frictionless. Sarah, would that be okay if we talked briefly about that?
Absolutely, yes.
Okay, great. So I'm going to share my screen, and Justin Mosby, who's our R&D and innovation manager, he's the expert of this. So Justin, let me share the screen, and please, if you could talk to that.
Sure, thanks, Nick. Thanks, Sarah. So we've been working with students from SIT. The students are not technical. So we do a lot of work we do with them is primary data collections, like what Nick and Pan has shared with you on police stations. So the police station is basically the police stations, the data set that Pan shared with you. We did a primary research of police stations along the Ottawa River, and we created a CSV file of that. And from there, we used Frictionless to create a JSON file. So how we worked with the student is that we did explain to them the big picture of what you are doing, the primary goal, and why you're using Frictionless. We introduced to them what data files are, the data files that we use in our infrastructure, like the CSV, JSON shape files, and also the data types. Like I said, they are not technical, so some of these terms are new to them. Context really matters, which is what Theodore had. Sorry. From there, we did a demo, a practical demo of how we created frictionless schemas previously, and asked them and gave them a data set to do the same. While they did that, we check their work. That is, for instance, the spellings, the data types, if they've entered them correct, captured them correctly, and of course, if they've input the descriptions on frictionless correctly. Next slide, Nick. So other than giving them a demo, we created a task on Asana so that they can go back and follow it later. And also we used Asana to assign them with the tasks on how they should create a frictionless schema once they finish collecting primary data. So this task is basically steps on what to do with screenshots, just simple screenshot, as you can see here, of where to start, the first step, the second step, to the point of validating the data and downloading the JSON file. So I can say, considering they're not technical people, Frictionless has really been so easy to use. It's so straightforward, and they did like it. They like the visual presentation that you can actually input more data and how you can load a CSV file, and the CSV file can actually preload most of the data that you have there. So the only challenge that they shared with us was they said if, for instance, you're working on Frictionless and you have a power interruption or anything happens to the browser, you simply like lose the data. And they also said, like, the error message, for instance, Frictionless does not accept caps in some of the naming when naming metadata. Like, the error message is not so clear. So that's the only feedback or challenges they faced, but we did like Frictionless. It's fast, it's easy to use, and it doesn't take a lot of time. Thanks, Nick, that's all.
Thanks, Justin, and thanks, Sarah, and the community for listening to us. Do you have any questions? Because we'll wrap it up there, but we're happy to talk more about it if there's time. Otherwise, you're welcome to contact us outside of this session.
I just had a quick question, if I may, regarding what Pan showed. So you're using the tools to see whether or not it fits, the data fits with the schema, but more often than not, do you find that they actually do fit, or how do you streamline it so once you get that listing of where the errors are, someone would have to go in and fix it? Do you find that most of them, or do you anticipate that most of them would be streamlined and able to go through?
So I think maybe Justin would be a better person to answer that question. So I assume before we get the data, when we receive the data, there is a stage of cleaning the data, and the data, I guess, was supposed to be cleaned according to the schema, so we know which how the data looks like and how it's structured.
Okay. And then you said that you get right now you get a list of where the errors are. So if someone wanted to go back and fix them, they could do that fairly easily. Okay, nice. Thanks.
Yeah, it would actually tell you which row and column that the error is.
Nice. Thank you.
Just to add to that, we had problems, all kinds of problems early on as we were starting to develop this. Again, it's a couple of years in the making. We're a bootstrapping company, so every time we can take some revenue and some time and effort to apply to this, we advance it. But we started a fair while ago before we knew about Frictionless, and there were all kinds of problems with the data. We were generating XML files from the CSVs at various points. The naming conventions were different. The columns were different. There were, misspellings, sometimes very hard to see. So that cleaning process was very painful, and it came from a variety of different people. And so we had to keep constantly going back. And one of the challenges we had, the way we were set up, is Justin and his team would gather data and produce it, and it was kind of being done on the fly, and Pan and I would be writing code on the other side. And there was a bit of a disconnect, because when we received that CSV file, in some cases, we couldn't tell whether that column, it was okay that a row in that column in a row was blank, or we didn't know if it was scientific data, what that meant. We worked with space data, and that satellite mission, one of the columns has this long set of numbers, and it doesn't make much sense. It just looks like, that should be an integer, but it turns out it's the date, it's the time that's elapsed since 1970, a very specific time for that particular satellite technology. We had no way of describing or understanding that, and the only way we were able to figure that out ultimately was talking to the mission scientists directly. So this is the kind of thing that Frictionless solves, especially on the scientific side, which we're getting into a lot of with the citizen science and the Earth observation. It's all physical sciences. We have no easy way of understanding the data at all, especially from a scientific perspective, unless we have this schema ready for us.
Nice. Thank you.
Dan, I think you had a question.
Yeah, I was curious, with the data sets that you're working with, how big do they get? And do you hit a point where your workflow starts to encounter problems when they hit a certain size?
We actually, our history and our DNA, we're a big data company. So I'm actually not very worried about that, but we haven't actually tested that with the Frictionless process. Really, our understanding is if we set up a data warehouse in Amazon that can have petabytes of data, and those are tabular, we're not anticipating big problems with the use of Frictionless, because worst case scenario, we can come up with a sort of parallelized validation structure. But at the end of the day, what's really happening is you're getting a CSV set of data, right? How big or small that is, it almost doesn't matter. It's intaked into the data warehouse or the big data pipeline. So I hope we're not wrong about that, but we kind of have just assumed that's not a problem. Maybe it will be. I don't think so.
Yeah, no, I was just curious, if you get into, millions or tens of millions of rows in some of these data sets, I wouldn't expect it's specific to Frictionless or any particular, framework in Python or whatever, but yeah, that architecture thing, if you do set up those kinds of processes, I think it'd be interesting for other folks to sort of, if your process, in addition to the code, could be shared.
We can test that. So the API that Pan showed is built on Amazon Web Services using Lambda. That could be swapped out with something else, but ultimately it's calling a Python script. So that's inherently scalable and can be parallelized relatively easily, although again, we haven't done that yet. So really what's happening is the act of uploading that CSV, there could be 1,000 of those CSVs being uploaded simultaneously to different, to the same API, and it would be handled using the Amazon network. So we don't anticipate problems, but ultimately what's happening behind the scenes is, as long as the CSV is valid, there's an ETL process that brings it into a data lake or a data warehouse that's more than capable of handling terabytes. So we think that's a solved problem. The part that Frictionless solves is so valuable. It's really understanding that this is valid data and also making sense of it from a development perspective. That's not something that any of these other tools do.
Cool, thanks.
Thanks, Lily. You had a question.
Yeah, I have a few questions, but I think that I'll try and just do them one at a time to let other people talk as well. But first of all, this is awesome. It's super exciting to see this. So thank you for sharing with us and for doing this work so far. I think we'll be following up with you a lot. But the first thing I wanted to ask you about is when you're building the app, I love the idea you have to do it quickly. Is that just your team would build it, or do you think that people on the ground could build it as well?
That is a great question. So it's a difficult answer, and I'll explain why. Our commercial activities, our goal is to unlock the value of Earth observation data. And there's been real struggles with that. Creating geospatial applications is historically challenging. It's a niche industry, and the satellite imagery and so on that's being used is hard to use. That's changing pretty quickly with all the satellites that are being launched and the new technologies and the new platforms and so on that are rising. But we set out to push a button and have geospatial applications created very, very quickly. And that's the effort we've been undertaking sort of commercially to make that dream a reality. In that spirit, although our ability to generate the solution very quickly is sort of a proprietary thing, the resulting solutions themselves are open source, actually under MIT and/or Apache licensing. So it sounds weird to say this, but we will open source the product that comes out of our factory, and that product relies on and uses open standards such as Frictionless very crucially. So what that means, to answer your question, I think is anybody could work on that solution. Could they do it as quickly as we could with our software factory? No. Could they extend what is produced and do more things with it? Yes. Is it our hope that when this is working, it's available to the world and people can sort of contribute to it? Yes. That's where we want to go. Again, because we're a bootstrapping company, we're kind of, as quickly as we can advance this, we do, but we're really reluctant to launch anything until we're sure that it's reliable and useful, because it's related to people's lives and property and disasters and impacts. But having said all that, everything we can share openly, we do. And it is our goal to launch this one day and to make it available. And we would expect people to be able to work on it, enhance it, and so on. So it would be an open standard. The results of the factory would be an open standard, but we'd probably be able to build such an application faster than anybody. That would be our hope.
Thanks. Do we have other questions?
Yeah. So, in what manner would this be deployed in a municipality? Would it be like on the city or county or state's responsibility to say, okay, we're going to use this deploy solutions app as our emergency response and disaster notification system, and then get all of the citizens in the area on board saying use this app? Is that kind of the approach, or
yeah,
it's
a good question.
The citizens would like elect into just because they heard about it?
Yes, I think that's a good question, and so that's still to be determined. But it would be complementary to such existing systems. Often there are systems, that there are web pages on the municipal website. There are, existing emergency response. What we find is missing is a centralized place where you can gather this information together, along with some things that aren't always considered, such as, where do I leave my pets while we're in the shelter? That turns out to be a data set that is an important one for people. So it would be complementary to some of these existing systems. It would probably be funded maybe at a level higher than the city. It might be at a state or provincial level or territorial level, or it might even be at the federal level. But ultimately, there would be a portal available in time of disaster. It would go live very quickly, and the new data that was necessary for those particular circumstances would be added. That's our thought. And because it would be done at a certain level, federal or state, provincial, or even municipal, it would be an area that people could be told to go through through these emergency response messages to say, here's some additional information. We verify that this information is correct, and we're managing it and monitoring it. And if you want to contribute your photos, you can do so here. Or if you just want to consume the news or the information that you need, it's on a map. It's over here. This is in addition to the other channels and the alerts and so on that we send you. Does that help, Jonathan?
Yeah, that helps a lot.
Thank you.
Do we have other questions?
I can ask my next question. So you're talking about extending the schema some. I'm curious if how that process was for you. Was it easy, hard, and did you document it in a way that maybe we could write a tutorial or something?
We haven't done it yet. mostly because we're still able to do what we need to do within the existing schema set. But we think that we will extend it probably, and our commitment is to advance knowledge wherever we can and to share things openly. So we absolutely commit to, when we do that, working with yourselves, documenting it. We believe in that. We work with a lot of students. So we actually have a student project right now working with CCAN. We're trying to figure out how we get our data into the data portals. So we're trying wherever possible to do experiential learning with people. And you know, I think students would be very willing to help us document such a process and to test that out. That's one of the ways we've advanced this research so much. Again, there's a million things we haven't talked about, but a lot of these concepts are first advanced by students testing something out as part of their course. So that's been very helpful to us to explore these concepts. And one of the reasons, the millions of reasons why Frictionless helps us is because that's the way we can standardize the output that the students are coming up with as they explore a concept and they're like, well, here's some new data sets. We're like, okay, you know, let's do a frictionless schema for that. So at least we know that those data sets are going to fit with everything else that we do. And we think at some point there will be something that don't quite have in the data set that we want to extend, probably for building applications. Actually, that's probably where we're going to extend Frictionless.
Awesome, cool. Yeah, we'd love to help in that process however we can. And while you're talking about training, hit on my last point, which is that we are currently developing a new version of all of our browser tool applications into like one mega application that will be better UI, more functionality. So a lot of the things I think Justin was mentioning about like that strange error message, we're working on fixing that in this new version. So keep an eye out for that as well.
That's wonderful news. Thank you. We will.
Yeah, thanks. And I wanted actually to echo what Lily just said. Justin, it's great to hear that you ask for feedback to the students. And whenever you have it, please let us know, because I mean, that's helping us making the product better, basically. I think we have a question from Augusto in the chat, which is, are you using any of the UN OCHA common operational datasets somehow?
Good question. We're actually overwhelmed by the amount of information that's out there ourselves. We've been working on this for 3 years, and in IT, as I think you all know, you're supposed to rush something out the door in a few months and then see whether it works or not. We've actually been working on this to make sure that we even understood what questions to ask. It's how many years it's taken us to talk to people and to just try to make sense of this. And now we've been working on this prototype for maybe 2 years. There's a lot of working functionality that's available. I think we're close to having something, but part of the challenge has been all the different data sets. I don't know that we've looked at that one per se, but we looked at a lot of the citizen science websites. We looked at a lot of the environment ministry websites of different countries. We've worked with experts in the UK and South Africa and other places to look at their data sets. So we're constantly, keeping an eye out for things that we can leverage, but our focus has been on understanding what we're trying to do and who we're trying to do it for, and then building the underlying technology to be able to build something in 4 hours or less, which is actually quite daunting. And I think we pretty much solved that problem, which is a relief, but that then means the next step is, okay, what are all these data sets? And that's one of the reasons we're looking at CCAN as well, because a lot of these environment ministries and others use CCAN portal, and we would like to. So we're early days into that. We have students working on that right now with Justin. But I think in that process, we will look at that data set and others, and the UN common goods, public goods. I don't know, there's a million data sets somewhere on the way. So we're totally swamped, but we do want to leverage what's out there.
Thanks, Nick. I think we have time for one last question, if anyone, or comment or feedback, if anyone has any.
I guess I can go again. So what actually is the product after your 4-hour time limit there? Obviously, you're not going to have a mobile app deployed through app stores in 4 hours. Is it just a website, a progressive web app? Like, what's the package that you're delivering?
You're absolutely right. It is that. It's a mobile-friendly web application for individuals and communities, and a secure mobile-friendly web app for the trusted authorities that communicate to each other. They are deployed in Amazon Web Services Cloud. They have API integration points, the ability to import and export data. They're using open source tools. And what else? They have the ability to allow citizen scientists observations. We are going to work on creating static versions of this information on the citizen and individual side, which will be accessible and fast to use, maybe even work offline. So that would be the product. The product is basically the ability to quickly create useful, practical advice and maps and associated tools, information for the people who are affected by the disaster or the people trying to help.
Everywhere.
Thanks.
There's another question for all of you, I think, in the chat, which is, can you share the slides for the people that arrived late?
Yes, happily. We'll send a PDF version to yourself, I guess, Sarah.
Great, that's great. And Yusuf, just to reassure you, we're going to put the recording of this call on the blog probably at the beginning of next week. So you're going to be able to see the slides from there as well, and the recording, of course.
Thank you for giving us the opportunity to speak about this. We believe very strongly in this, the value of frictionless, as I think you can see. And, you know, there's lots of things we haven't talked about, but even just hearing the backgrounds of this community, you know, we recognize the importance of science and observable truth in this world. And we think frictionless is a key element of that.
Thanks, Nick. And thanks for proposing to give this presentation today. It was really, really awesome to have you, Pan, and Justin as well presenting. Maybe I'll just close with some last little points that we want to share with the community, which is a reminder, first of all, that the next community call is in 1 month on the 30th of June, and we're going to have the Frictionless Fellows. So that's something that maybe is interesting for you, Justin, because we also have a training program for students that Lily is leading. So it could be interesting to maybe have also like the kind of curriculum that you have for your training and sort of like compare it. Anyhow, we're going to have the Frictionless Fellows on the 30th of June. So they're going to present and you're going to be able to meet them all. The other announcement that I wanted to make, as most of you know, our community moved from Discord to Slack, and now finally we have a Matrix bridge available as well. So please join the Slack community also via Matrix if you want. And then the other thing is maybe an open question. If anyone here wants to present the project to one of the Frictionless community calls in the future, please let us know. There's a form in the notes, but I can share it here as well. So just fill it out if you want to present in one of the next community calls. I think that's it from my side. Lily, do you want to add anything?
Just thank you all. It was a really helpful presentation, and it's nice to see everyone's faces.
Yeah, absolutely. Thanks all. Have a good rest of the day. And Pan, Nick, and Justin, thanks again for the awesome presentation. We'll get back to you to have more info and maybe write something down and some future collaborations.
Thank you so much.
Thanks, everyone. Bye. Have a good day.